In this video, we're going to talk about a certain type of simple machine known as the pulley. Now, the pulley is a machine that can help us to multiply the force that we exert to lift up objects. In this picture, you can see this person trying to lift this 400 Newton crate. The question is, how much force does he need to exert in order to lift up this crate? Let's ignore the effects of inertia and friction in this problem. Well, we know that the weight force that gravity exerts on this object is 400 newtons. And in order to lift it, we need a force of at least 400 newtons in the upward direction. Now notice that we have two ropes. In an ideal situation, the forces acting on these two ropes, also known as the tension force, is going to be the same. If they're the same and they have to add up to 400, that means that they both have to be half of 400. So the tension in a rope is always going to be the same. So the tension throughout this rope is 200 newtons, which means this person is pulling down with a force of 200 newtons. Now let's think about what this means. He's applying an input force of 200 newtons, but the pulley is lifting up a 400 Newton object. The pulley is applying an output force of 400 newtons. So this machine magnified the man's force by a factor of 2. The ratio of the output force divided by the input force is 2. And that is the mechanical advantage of this particular pulley system. It's equal to the output force divided by the input force. And that's the purpose of this device. It allows us to multiply the force that we input to this machine, making the work a lot easier to do. Now, there is a cost to pay. This multiplication of force does not come free. In order to lift up the crate by a distance of 1 meter, the person has to pull down the rope by a longer distance of 2 meters. Why can we say that? Well, as he pulls down this rope by a distance of 2 meters, this rope is going to go up by 1 meter because this rope is going to go up by 1 meter. So 1 meter plus 1 meter equal a change of 2 meters on the other side. So if this goes up by 1 meter, the distance here decreases by 1 meter. And this part is going to decrease by 1 meter. So this has to increase by 2 meters because the rope is not going to gain or lose length by any chance. If these two ropes go up by a total of 2 meters, then this rope has to go down by a total of 2 meters. They have to add up and be equal to each other. Now, if these two ropes go up by 1 meter, that means that the crate only moves up by 1 meter. And in that sense, there's a change in distance. So when a person pulls down a rope 2 meters, the crate goes up by 1 meter. Now let's calculate the work. Work is equal to the force times the displacement. So we have a force of 400 newtons and the crate is being displaced 1 meter higher. So 400 times 1, we're applying 400 joules of work on this crate. Now the person is applying a force of 200 newtons for a distance of 2 meters. So 200 times 2, the work that he's applying is 400 joules. So the pulley doesn't change the amount of work that needs to be done. However, it simply changes the force that you have to apply by changing the distance. So because the person pulls the rope for a longer distance, he can apply a lower force in order to lift the crate over a short distance. And so that's how these simple machines can multiply the force that we need to get the work done, is by changing the distance over which that force is applied. So if we want to create a large force acting over a shorter distance, we need to apply a small force over a longer distance. And that's the principle behind these machines, how they work. but the energy that's needed to get the job done is the same. Energy is neither created or lost in this process. So the law of conservation of energy is consistent with this device. Energy is not created or destroyed here. Now, there's something else that you want to take into consideration, and that is that the mechanical advantage of the pulley is equal to the number of ropes that is being used to lift up the crate. Notice that we have 2 ropes being used to lift up the crate, so the mechanical advantage is 2. Now let's look at another example, but one that contains more ropes being used to lift up the crate. Now looking at this pulley, what would you say the mechanical advantage is? Notice the number of ropes that we're using to lift up the 800 Newton crate. We have a total of 4 ropes being used to lift it up. Therefore, the mechanical advantage is simply going to equal 4. So just by knowing that, we know that the person is going to apply an input force that is 4 times less than the force we see here. So 800 divided by 4 gives us an input force of 200 newtons. Now let's think about why. We need to lift up a weight or a crate that's 800 newtons. And all of the forces here in this rope are going to be the same. And they have to add up to 800. So it's 800 divided by 4, which is 200. So this is going to be 200. This is going to be 200. And this is going to be 200. And that's 200 as well. So if you add up 200 newtons 4 times, you get a total force of 800 newtons. So thus, the mechanical advantage is equal to the number of ropes being used to lift up the crate. And as we can see, the tension in the rope is the same throughout the entire rope. Now let's talk about the distance here. In order to lift up this crate a distance of 1 meter, how far should the person pull down the rope? Well, in order for the crate to go up a distance of 1 meter, each rope has to go up by 1 meter in an ideal situation. So we have 4 ropes going up by 1 meter. That means that this rope has to go down by a total distance of 4 meters. And thus the work that is applied is equal to lifting up an 800 Newton crate by a distance of 1 meter. So that's going to be 800 joules. And on the input side, we're applying a force of 200 newtons over a distance of 4 meters. 200 times 4 is 8. So we can see that the work that we apply at the input is equal to the work applied at the output, given a situation of 100% efficiency, if no energy is lost due to friction or dissipated in the form of heat. Now, with this type of device, you can have any number of ropes that you want. If you were to use 10 ropes, your mechanical advantage will be 10, which means your force will be multiplied by a factor of 10. However, you will have to pull down the rope a distance that's 10 times as much. So by pulling the rope 10 meters down, the crate will only move up by 1 meter. And that's the cost you pay for force multiplication. Now, there's something else that we need to talk about when dealing with this type of pulley. In an ideal situation, each of these ropes will move up by the same distance. But if you were to actually try this experiment, you'll find that the ropes on the left will move more than the ropes on the right. And this rope may not even move much at all. And this particular pulley might be tilted towards the left. But in the ideal situation, we're assuming that all ropes move up at the same time. But that's something you want to keep in mind if you were to actually try this experiment. The ropes on the left will appear to move more in the upward direction than the ropes on the right, for the simple fact that they're closer to this rope. Now let's take a minute just to review what we've learned regarding the pulley. The mechanical advantage of the pulley is equal to the number of ropes. It's also equal to the output force divided by the input force. And in order to increase the force at the output, you need to apply a smaller input force over a longer distance, and you're going to get a larger output that's going to move over a shorter distance. And second, the input work is equal to the output work if you neglect things like friction and any energy losses dissipate in the form of heat. So those are some things you want to know when dealing with the pulley. So that's it for this video. Thanks for watching, and don't forget to subscribe to this channel.